December 2025 didn't just mark the launch of a new energy project. It completely rewrote the definition of massive in the electrical engineering dictionary. Saudi Arabia has officially fired up the largest battery energy storage project in history, boasting a staggering capacity of 7.8 gigawatt-hours. To grasp the sheer magnitude of this number, we have to place it next to the previous record holder, the Edward Sanborn project in California, which topped out at 3.3 gigawatt-hours. We aren't talking about narrowly edging out the competition here. We're talking about more than doubling the world record in a single strike. This isn't just one massive centralized block. It is a network distributed with surgical engineering precision across three critical nodes in the Saudi grid: Najran, Madaya, and Khamis Mushait. Selecting these specific locations in the south and west wasn't random. It was a calculated move to reinforce the grid's extremities in rugged terrain notorious for load fluctuations. The execution was led by China's Sungrow in alliance with Saudi Arabia's Al-Gihaz Holding. Together, they deployed the absolute bleeding edge of storage tech, the PowerTitan 2.0. But what's truly mind-bending isn't just the total capacity, it's the energy density. The project consists of over 1,500 containers. Each standard 20-foot box packs 5 megawatt-hours of storage. Effectively, they've compressed enough energy to power an entire neighborhood inside a single shipping container. This density was key to shrinking the physical footprint. Now, typically, billion-dollar infrastructure projects take 2 to 3 years to complete, but official data from this project reveals a timeline anomaly. How did Saudi Arabia and China manage to install and commission 7.8 gigawatt-hours in just 58 days? The secret behind the 58 days lies in completely abandoning the concept of on-site construction. In the past, battery plants were built piece by piece in the desert, cells, wiring, cooling, inverters, all installed separately. Sungrow flipped the script. They turned the power plant into a pre-assembled product. The PowerTitan 2.0 containers arrive at the Jetaport fully loaded: batteries, energy management systems, power conversion systems, and fire suppression, all integrated and pre-tested at the factory. The role of engineers on site shifted from construction to plug-and-play. This method, known as AC-side storage, eliminates thousands of manual labor hours and drives the margin for human error down to near zero. Logistically, this required moving tens of thousands of tons across the ocean with millimeter precision distribution. But this speed wasn't for bragging rights, it was an economic necessity. Every day of delay meant wasting millions of kilowatts of solar potential. But why does Saudi Arabia, the king of conventional energy, need the world's biggest battery? The answer lies in a terrifying phenomenon on grid control screens: the duck curve. The intense desert sun generates massive, cheap power at noon, but peak human consumption hits after sunset between 6 and 9 p.m. This creates a dangerous imbalance: a sharp drop in demand during the day, followed by a violent spike at night that slams the grid. Gas turbines simply can't ramp up fast enough to cope. Enter the batteries. They act as a massive shock absorber, soaking up the solar surplus by day and unleashing it at sunset. Crucially, these batteries support grid-forming technology. They simulate the physical inertia of traditional generators, giving the grid virtual stability and allowing for higher renewable penetration safely. But there was one more enemy: the heat. Cramming this much lithium and current into a 122 degrees Fahrenheit, 50 degrees Celsius desert is usually a recipe for disaster. The solution wasn't giant air conditioners. Instead, they borrowed liquid cooling tech, similar to what you find in high-performance EVs and microreactors, to keep the system stable. Completing this project sends a powerful signal to global markets. Saudi Arabia, holding the world's largest oil reserves and now its largest renewable storage, is repositioning itself as the central bank of energy. The transition from burning liquids to storing electrons is the mandatory path for major economies in the coming decade. Furthermore, the collaboration with China proves Beijing has officially won the clean energy supply chain race. Delivering 7.8 gigawatt-hours in under 2 months is a feat that current US and European factories combined simply cannot match. It's a sobering reality that dictates new alliances. This project paves the way for electricity exports. With grid interconnections to the Gulf and plans for Europe and India, these giant batteries serve as warehouses, allowing the export of solar power even at night. What we see in Najran today is the prototype for the global grids of 2030, decentralized, flexible, and smart. Batteries are no longer just an accessory, they are the beating heart that keeps the grid alive when the sun sets. The equation is simple. Whoever controls energy storage controls the future. And with this project, Saudi Arabia has proven it has no intention of giving up the lead, whether the fuel is black oil or clean electrons stored in white boxes. I'll see you in the next one.